Hello everyone. So what I'd like to cover in this video is something that we covered this week in class at both Becker College and Lesley University, which is preparing objects for rigid body destruction in Houdini. And since we're using Maya at both schools, this is the application that we'll typically do our prep work in. So I have a torus and a cube, so not really anything fancy, but it will get the point across. I might move a little quickly here because I feel like there's a lot of steps to cover, and you can just certainly pause the video and rewind it when necessary. So the first thing I'd like to say is that the easiest thing would be to separate all the pieces that might require different types of fracturing, like wood versus concrete versus glass and so on. Now in Maya, I have these two pieces combined. I selected both polygon objects and went to the mesh menu and did a combine. Now, as we discussed in class though, Maya still remembers that they are two separate pieces even though they're combined. See, if I click away from it and click on it, it selects it as one piece. You can also see over here in the outliner that there are some empty transform nodes, and those are actually left behind because I didn't delete the construction history after combining these two, which is something that you want to do whether you're working in Maya or Houdini or any other application. When you're done modeling in Maya, you want to delete your construction history so that it doesn't leave any of this extraneous information behind. So I'm going to go ahead and do that now. So I'll go to the edit menu and go to delete by type history, and you see those extraneous transform nodes are gone, and now I just have one object. Now I still can access these independently. If I zoom in here a little bit and then I'm going to right click and open up the marking menu and choose the multi-level. This is a level that Maya has that remembers what the objects were that were originally combined. So if you have a model in Maya and it's made up of multiple pieces that you need to separate, I would suggest using this component level to see if you might be able to separate them. So I'll go to the multi-level, and with the multi-level what I need to do is just double click on a polygon somewhere. So like I have here selected. If I double click on it, you'll see that it indeed did find the torus geometry inside that combined geometry piece. And same thing would happen here with the cube. If I double click on a polygon on the cube, I can isolate just the polygons that make up the cube. So the fact that Maya remembers them that way, even though we combine them, is a very useful and handy thing. What I'm going to do is come back up to the object level here, and if I wanted to separate these, because I wanted these to become two different rigid body fractures in Houdini, I could come up to the mesh menu and just choose separate, and it will pull them back apart again. So again, I think the most straightforward way to work is if you can separate out your different pieces that are going to be separate rigid body destruction in Houdini, go ahead and do that in Maya. Now, if we can't do it in Maya, I'm also going to talk here a little bit about how we can make those separations or create those separations in Houdini. So what we need to do now is get this out of Maya and in the Houdini. I'm going to do that two ways just so we can look at the differences, just like we did in class. I'm going to export it as an FBX and export it as an OBJ. And I can do that from the File menu here, just File, Export Selection. So I'm going to pause the video for a second and just export these and then pick back up in just a minute. Okay, so I exported the cube and the torus as one object in both FBX format here and OBJ. And of course, OBJ also gives us this additional MTL or material file. So again, just to review that, I went to File, Export Selection, and then I exported it in both of those formats. So now I'm going to jump over to Houdini and see what these look like when I import them in. So let me bring Houdini up here. And I'm going to do File, Import. Now I can do geometry or I can do specific file format. So if I bring in the FBX first, I can choose this one here, the Filmbox FBX. But I could also get it through geometry. Geometry gives me all formats. So I'll do Filmbox FBX. And oh, actually, before I do this, the other thing that we talked about in class that I want to mention here is that we want to make sure that our Houdini file is also in this folder before we import any of these models, because Houdini makes a direct connection to external files. It's not like Maya, where if we import an FBX in the Maya, the actual geometry of that FBX resides in the Maya file. Houdini doesn't do that. It's always setting up a path to any file that's imported. So we need to make sure that they are in the same folder together before we import them, so that we design, or so that Houdini creates a relative path to the object. So before I import that, what I'm going to do over here in Houdini is just go File, Save As, and I'm going to put this, so I'll go to my folder on the desktop here, and I'm going to save my Houdini file. So I'll just call it Torus Cube. So now my project file also has the Houdini file in it, alongside the actual models. So now if I do File, Import, Import, there we go, FBX, and then I click on the Browse button here, you'll notice that it is referencing, by default it references $hip, which means it's looking to wherever the Houdini file is saved. That's why it was important to save the Houdini file first, because this is a reference to wherever the Houdini file is. And if the Houdini file isn't saved anywhere, it doesn't understand what that reference path might be. It'll actually go to a default location, which is where I don't have my files. So there's my FBX, because I told it I'm looking for FBXs. So I'll choose this one, and I'll hit Accept. And then in here, just right down at the bottom, I can either import as a new scene, which closes the file that I'm working on, or I can import into the current scene, which is what I want to do. So I'm going to click on that, the import button. And now my file comes in. So when we bring the files in FBX format, they're going to have a little bit different structure over here in the network view than if we bring in an OBJ. And whichever format you use is sort of personal preference. Now, the first thing we want to be aware of, though, is the size of this object. So Maya is actually about 10 times larger than Houdini. So that means that this is 10 times larger than what it was in Maya, and therefore Houdini can have trouble simulating at such a large scale. We want to bring everything down the Houdini size. So what I like to do is just create a Houdini box. So I'll control click on the box so that I can make one of these, and we can see that's the size of the Houdini box. So actually in this case it's not too bad. So this is 1 meter by 1 meter. So depending on how big this object is in the simulation that I want to create, I will determine whether I need to scale it down. A lot of times you need to scale the models down. You don't want to try to sim them when they're really, really large. So I just create a Houdini box knowing that Houdini thinks this is 1 meter by 1 meter, and use that as a scale reference for my object. So in this case, if my object is too big, what I'd want to do right here at the top level is lower the uniform scale. So maybe 0.01. Now that's going to be really small because the model that I worked with in Maya, I actually didn't make it very big. So in this case, I think I'm okay, but you need to double check that. If you have a garbage can that you created in Maya and you bring it into Houdini and it's 100 times larger than Houdini's default cube, then you know you need to scale it down. So that's one thing to be aware of. So in this case, I think the scale is fine, so I'm going to leave it that way. And let's take a look at what the nodes look like. So when you import an FBX, it comes in a node called a subnetwork. So if I double click on that subnetwork, I come in here and I'll usually have a material node that houses any materials that we created, which there weren't any in Maya, so it's essentially empty. And then in here is where we actually find the geometry node. Right there it is. And notice it has the same arbitrary name it had in Maya, ptorus2. So now if I double click on that, I am now inside the geometry network. This is where I can set up my fracturing, whether I'm doing a Voronoi fracture or a RBD material fracture, which are the two we've been discussing the last 2 weeks in class. So when you're working with the with importing in FBX, you have to know that your actual geometry node is buried one level deep inside this subnetwork. Now we can get it out of the subnetwork if we wanted to. I could just go back into the subnetwork, grab the geometry, copy it, come back up to the very top level of my object level actually, and paste it, and then just remove the subnetwork. So now I'm up at the top level. So that's how we would deal with an FBX import. So let's look at what the OBJ looks like. Actually, yeah, let me undo that so I'm back to the subnetwork. All right, so that's FBX by default coming in with the geometry node embedded in here. And then inside the geometry node, you notice it's not geometry, it is actually a file node. So it's looking to that object, that FBX object. But here's where we can treat this as if it's a Houdini primitive, and then we just start tacking on our fracture nodes after this. All right, so now I'm going to import the OBJ. Let's see how that imports. So I'll go File, Import, Geometry, because I don't have a specific type here for OBJ. So I'll do Geometry, and I'll grab my OBJ object and hit Accept. So here's my OBJ. Now I'm going to turn off the FBX. That's this one. Of course, they're going to look identical. They're right on top of each other. But you'll see it brings it in. It doesn't bring it in a subnetwork. It brings it in as a geometry node. And then right inside the geometry node is the torus file node. And it tells us here, it's referencing from where the Houdini file is, $hip, and then the name of the object, which is torus cube OBJ. So personally, I kind of like the OBJ format better. It's a little cleaner import than what we get with an FBX. But there are times that an FBX is more beneficial, especially if you want to bring camera data in and things like that. You know, if you're building a simulation where some person on the team or you yourself has done camera tracking, we know FBXs can import cameras and camera animation data. It holds a lot more information than what an OBJ does. But if it's just the straight model that you need without any other data like camera animation, then we can import with OBJ and get a slightly cleaner import. So the next aspect that I want to cover is how we can set up fracturing for these objects. So I'm gonna actually remove the FBX and just work off of the OBJ. So I remove the FBX, and now what I need to do in here is I need to separate these two pieces. So let's say, for instance, I did not separate these in Maya and import them as separate objects, which I didn't do. That's actually what we did not do here. So this is one solid object. Again, if we had separated this in Maya and brought the cube in as an OBJ and the torus in as an OBJ, we would just basically have two geometry nodes here, and we could start building our fracture nodes in each one of those. But in this case, I'm gonna show you the method we talked about in class for how we can do some separation directly in Houdini, and then also build our fracturing for the individual objects inside one geometry node instead of having two geometry nodes, one for the torus and one for the cube. So I'll double click on this, and there's my file. So now what I need to do is I need to figure out how to separate these. When we isolate or separate objects in Houdini for fracturing or for any other system that we might be creating, it's typically a combination of a group and a blast. We have to group, which basically means we need to make a selection. A selection in Houdini can be saved as a group. And then we use that group to determine what we're going to keep and what we're going to delete. That's called the blast node. So I'm going to put down a group node. So I'm going to right click in here, go to the group category. There are lots of group nodes, but the big workhorse that you're going to use all the time is the one called group. So I'll select that one, group. And let's see if we can get the cube independent of the torus. So I'm going to call this group cube group. And in its name here, the group name, this is the name that's pushed down to additional nodes, such as the blast node. So what I usually do is whatever I give the actual node name, or whatever I name the node, I'm also going to give the group name the same thing. So I'll call it cube group. And I need to determine what I'm grouping here. And I'm going to group primitives because I want the whole object, so I'll leave it as primitives. And then typically what you can do is sometimes if we've set up selection sets in another application like Maya, we can usually access them here. Now let's see, it doesn't look like, it does have one called ptorus2, which is just the whole thing. All right, so that's not going to help me. Okay, but it's always worth a shot to hit this drop box and see if there might automatically be groups that you can isolate coming in with the geometry. Sometimes we'll get that in FBXs because FBXs can carry group information, whereas an OBJ can't. So that could be one reason why I'm not seeing these as two separate group objects or two separate pieces of group information here. So in this case, I'm going to have to do it manually. So there's really, when you're working with the group node, there's really two primary tools that we use. We either do a manual selection, which is what we do here under the base group category, or we can do keep in bounding region, which creates a volume and whatever, it's either a sphere or a cube volume, and whatever primitives are inside that group or inside that volume will become part of the group. Now I'm going to do a manual selection here. So here's how this works. I have to click the little select button right here. And then I can come over here and I can start to make selections. Now, how you make the selection is up to you. Like we can do a rectangular marquee. We have paint tools, lasso tools. They're all right here along the top. Here's select only visible polygons or all polygons. So we have all those typical selection tools. In this case, I should be able to do just like I did in Maya, where if I double click on a polygon, it will grab all of the objects that are in that particular object, let's say, from when it was combined in Maya. So I double clicked on one of this cube's polygons, and you see it's gotten all of the polygons for the cube. So that's great. Now what I need to do is, with my cursor still in the viewport, again, this is an odd little quirk of Houdini. I can't put it out here anywhere. Once I make that selection, I have to keep my cursor in here, and then I'll hit the Enter key. And now it looks like it jumped me out of the network. I'm not sure why, but let me jump back in and come back to my group node. And you'll see it now has added the polygons with these IDs to that group. Right there they are. So now I've just isolated the cube group. So now what I'm going to do is I'm going to do the same thing and create a group for the torus. So I'm really scrunched here with my recording area, so you have to bear with me. So I'm going to create another group node, which is being cut off here. And I'll wire this one into the incoming torus object. So I'll call this group torus group. And I'm going to copy that name, and I'll also make the group name torus group. All right, so I have my cube group, and now I have my torus group. So I'm going to do the same thing here. With my torus group node selected, I'll click on the select button under base group, and then I'll double click on a polygon that is connected to the torus. And it selects all of those connected polygons. And then I'll hit the Enter key. Now that time it didn't bump me out of there. I'm not sure why it did that the first time, so that's kind of unusual. But so now you'll see I've got the two groups. There's my cube group and there is my torus group. So now I've just made two groups from this imported object that came in as one object. So again, in Houdini, you can think of these are just selections. That's what these groups are. But now what I can do is isolate what is in each of these groups. Because right now it's just a selection. It doesn't mean that this path of nodes that I'm creating here is only going to be affecting the cube group, I need to tell it that there's only the cube coming down this path. So that's where we add the blast node also. So I'm going to right click. I'm not sure where the blast node resides, so I'm going to type in BL for blast, and it comes up right there. So I'll put the blast node down and wire it in. Whoops. Here we go. Wire it in. And I'll put my display flag on it. And now everything disappears because it blasts or deletes everything. Now what I'm going to do though is I'm going to tell this blast node to be isolated to a certain group. And here it's going to be the cube group. That's the name that I gave this. So what it's actually referencing that name right there. So that's why it's important to give this a descriptive name in your group node. So I'll come back here. I'll say I want you to confine yourself to the cube group. And it did the opposite of what I wanted. Again, it's a blast node, so it's saying, okay, well, whatever is in that cube group, I'm going to delete, which is the cube. So what I need to do is just select this box here that says delete non-selected. And now this path only contains the cube. So now I'll do the same thing over here for the torus. So I'll put down another blast node, BL for blast. And I'll wire my torus group node into it, put my display flag on it, and I want to tell it to isolate itself to the torus group. And then delete non-selected. So now I have the torus. So what we have here, let me move this over a little bit. What we have here basically is the imported file. Then I created one group that's just the cube and another group that's just the torus, and then I blasted away what wasn't in that group. So now this path is only the torus and this path is only the cube. And now I can start building my fractures in here. So I'm going to go ahead and do that. I'm going to keep this pretty simple. I think I'm going to use the RBD material object, or RBD material fracture node. Yes. So I'm going to right click in here, and this is being cut off at the bottom. I'm going down to the RBD category, and I'm choosing the RBD material fracture node. So that is this node here, which usually takes a few seconds to compile. RBD material fracture. So I'll wire my blast node into the geometry input. And we see it gives me a fairly basic concrete, which is actually a Voronoi fracture. So that's going to be my fracture here. I'll do the same thing for the torus. I'll put a fracture on that. So same node, RBD category, and then the RBD material fracture. And this video is getting quite long, so this will be a long one for us. Oops, and I just missed my connection there. There we go. Okay, so if we look at this one, we see I have some fractures here. Now I have other videos for working with the RBD material fracture node, so I'm not going to go into that here. This is really just about the structure for bringing in and separating files for fracturing. So I have two material fractures. So now what I need to do is I need to turn these into RBD objects. So what we need to remember about the RBD material fracture is that if we generate an RBD object from this, Houdini is going to make all kinds of unusual connections between the geometry output, the constrained geometry output, and the proxy geometry output. We're just going to go with a really simple fracture. So I want to force Houdini to only build its simulation nodes that it needs for the RBD object right off of the geometry output node. So I'm going to do that with a null. So I'll right click, type in NULL for null, and I'll put down a null node. And I'll wire the null into here. And typical Houdini naming conventions, we usually go with out, and then I'll call this is the cube. So I'll say out cube frac for fracture, out cube frac. And I'll do the same thing with the torus. Right click, add a null, and I'll call it out underscore, this is the torus frac. So now we're ready to go there. So now what we need to think about is how Houdini sets up its nodes for the simulation. We know when we come up here to the rigid body shelf, right here, I'm opening up so we can see this, rigid body shelf, and we make an RBD object. What Houdini does is it goes into whatever node selected, because we have to use this shelf tool here, the RBD object. That needs to be done up here at the top level. Well, we have two different fracture pieces inside there, the torus and the cube. So how's Houdini going to know which one of these to generate the simulation nodes from? So with an RBD object, it's going to create in here, it's going to create a rest node, it will create an assembly node, and a DOP import node. So what we want to remember is Houdini will go with whatever node has a display flag on it. So I'm going to start with the cube. So I'm going to put the display flag on the cube's null. Then I'll come back up to the top level here and click on the RBD object shelf button. And it makes the auto DOP network. But let's look what's inside the torus cube geometry node now. We see it added the rest, the assemble, and the DOP import right off of that node that I had the display flag on, which was the out cube fracture null. So this is how we can basically create multiple fracture node paths, if we want to call them that, one for the cube, one for the torus here, and then tell Houdini which one of these paths it should generate the RBD object from. So I can just repeat the same process here. Put the display flag on the out torus fracture null, and then come back up to the top level, and with that geometry node selected, I can create or click on the RBD object button again. And now we don't see anything happen here because it's all being fed into the same DOP network that had already existed. But if I go into the geometry node one last time, we'll see we now have two sets of rest, assemble, and DOP import. So this one is communicating with the DOP network using DOP import 2, and this one is communicating with the DOP network using DOP import 1. Now the real challenge though is how do we see the results of this? Because inside any given geometry node, I can only put my display flag on one node. So we can go back to a node that I think we had used at the very beginning of the semester, which is the merge. So I can right click in here and type in MERG for merge, put down a merge node, and now I'm merging the results of the DOP import 1 and the DOP import 2, and now I'll get my simulation. At this point, if I play it, it's just going to fall away because there's nothing there for it to interact with. So what I might want to do is come back up to the top level, go to my collisions shelf, and just add a ground plane, which is actually intersecting everything. So I'm just going to move the ground plane down a little bit. And now if I run the simulation, we see I have two separate simulated pieces, all from the same object that I imported. I imported a single object from Maya, but then I separated these two pieces out using the group and the blast node in Houdini. So again, back in the geometry network, I just simply have, here's my imported file. Then I made a group that isolates the cube and another group that isolates the torus. Then I blasted away the non-selected components accordingly, generated my fractures, in this case with the RBD material fracture. Then I guided Houdini for each one of these, guided Houdini to build its rest, assemble, and DOP import off of the geometry out of our fracture node. And then I just merge the two results back together. And if we take a look at our AutoDOP network, that should have basically just two RBD packed objects. One is communicating with the torus, and the other is communicating with the torus and the cube. Actually, this is terrible naming conventions on my part, because they're both is called torus cube 1, torus cube 2. I have to actually look at the SOP path to figure out what it's doing here. I probably should have named them more appropriately over in my geometry network. But if I look at this one, it is communicating with the so there's DOP import 1, and this one is DOP import 2. So DOP import 2 is the torus, and DOP import 1 is the cube. And just to double check that, I can come back over here to the geometry network. There's DOP import 1. That's the cube. DOP import 2, that's the torus. I could change these names. I could say DOP import. This might make it easier to decipher if we're working in the DOP network. Torus. And this one, instead of DOP import 1, I'll call it DOP import cube. So now let's see what that looks like back over in the AutoDOP network. And the name hasn't changed here. This is, we could change these names too, which I should probably do, but you'll see now it does say DOP import cube. And this one says DOP import torus. So that helps a little bit, but we might just change a name in here. This first one is the cube. So I'll just call it cube, and this one's the torus. So I'll call that torus. Cube and torus. What's interesting though is this is also showing us how these two nodes, the RBD packed object nodes, are communicating with those DOP import nodes. We can see that here. The cube RBD packed object is referencing the DOP import cube, and the torus is the DOP import torus. Now I renamed these two nodes here, so we'll probably see a change over in the geometry network as well. If I open up the geometry network and I go to the DOP imports, there's DOP import cube. It tells us that it is looking for the object called cube, which is the RBD packed object that I just renamed over there. I renamed it to cube. And DOP import torus is referencing that RBD packed object that I renamed torus. So you always want to keep an eye on these, the object mask in here and the SOP path here. That's where we can see what the two nodes are communicating with. So I think that is the basics on how we can import an object from Maya. And in this case, if we bring the object in from Maya as a single object, we can start separating it out with group and blast nodes in Houdini. But a more straightforward method is just to simply separate the cube and the torus in Maya and then import them as separate objects. So I hope that helps.